Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve the next revision questions from question 21 to question 30. So let's start with our first question, question number 21. A simple question, a useful method for a pilot resolving on a visual flight any uncertainty in the position is to maintain visual contact with the ground and do what? Set heading towards a line feature such as coastline, river, motorway. Fly the reverse of the heading being flown prior to becoming uncertain until a pinpoint is obtained. Fly expanding circles until a pinpoint is obtained. Fly reverse headings, associated timings until the point of departure is reached. So the most appropriate answer will be option alpha. Always set your heading towards a line feature like railway line, motorway, coastline. Follow that thing, and because when you follow that thing, you will be in touch with the ground surface always. You will always find a population, settlement, area, city, and you will be able to know where your aircraft position is. Rather than flying reverse headings, expanding circles or timers, and waiting till you find out a pinpoint, that will waste your fuel, that will that will increase your confusion and stress you out. So it's better to follow a coastline, river, or motorway. This coastline, river, motorway you can also find on your aircraft, the maps that you are using in your aircraft, and that will help you to go to a familiar place and then go back to your departure airport if you want. So follow this. Next, question number 22. Aircraft is at flight level 140 and indicated airspeed of 210 knots, outside temperature of -5 degrees Celsius. Now with this three pieces of information, indicated airspeed, altitude, outside temperature, you can find out true airspeed. You can find out true airspeed using your CX3. So CX3, you have to substitute the values of pressure, altitude, your outside air temperature. Okay. So in this option, that is option airspeed, the outside air temperature in Celsius is what? -5, right? So right, press the button 5 button and then press this plus minus button to get -5. Calibrated airspeed or indicated airspeed is 210 knots. Altitude is 14,000 feet. So your true airspeed will be -5 Celsius, 210 knots, 14,000 feet. True airspeed 262 knots. True airspeed 262 knots. Now the wind component here is -35, meaning headwind of 35 knots. So headwind 35 knots. So ground speed will be equal to true airspeed minus headwind 262 minus 35, 227. 227 knots. Okay. So this is your ground speed. The distance is 150 miles. So you will travel 150 nautical miles at a speed of 227 knots. In what time? In 39 minutes. In 39 minutes. Now the ATC has told you, instructed you to arrive at the beacon 5 minutes later. To lose 5 minutes to arrive means to arrive at your destination 5 minutes later. Okay, 5 minutes late. So ATC wants you to arrive. So I'm writing here, new time of arrival is 5 minutes late. 5 minutes late, that means 39 minutes plus 5 minutes. So ATC wants you to arrive at your destination point at 44 minutes. Not at 39 minutes, but 5 minutes later, that means at 44 minutes. After 44 minutes, you are expected to arrive at point B or your destination. Now, if you want, this means if you want to arrive late somewhere, what do? You decrease your ground speed. You decrease your ground speed. Now, over here, our initial ground speed is 227 knots. The distance is 150 nautical miles. The time, what is the new time? 44 minutes. Our final ground speed will be, the distance is going to remain constant. What is the final time on new time of arrival? 44 minutes. So 150 divided by 44 gives us of a new ground speed of 204 decimal 5. That is approximately 205 knots. So initial ground speed is 227 knots, and now it has decreased to a value of 205 knots. So new ground speed is 205 knots. Now with this you can find a new true airspeed. What will be the new true airspeed? New true airspeed will be ground speed minus plus headwind plus headwind. Okay, so that will be equal to 205 knots plus headwind of 35 knots is equal to 240 knots. This is your new true airspeed. Now from this new true airspeed you will obtain new indicated airspeed using CX3. We obtained this true airspeed from CX3 using indicated airspeed. Now we will go reverse. We will follow a reverse procedure. Now from this true airspeed we will find indicated airspeed. So true airspeed of 240 knots, new true airspeed of 240 knots, temperature minus 5, and pressure altitude of 14,000 feet. So this gives us a corresponding calibrated airspeed of 192 knots. So our new indicated airspeed is 192 knots. What was the initial indicated airspeed? It was 210 knots. So how much has been the decrease? It has decreased by 18 knots. It has decreased by 18 knots, approximately 20. So the correct option will be option delta, 20 knots. Next, question 23. Distance between x and y is 30 miles. Actual time of, so departure time is 14:20. You depart from x at 14 hours 20 minutes. You arrive at y. Your actual time of arrival is relevant. 14 hours 50 minutes. That means your time is equal to, flight time is equal to 30 minutes. This gives us a ground speed of 30 nautical mile divided by 30 minutes, a ground speed of 60 knots. Now with this ground speed of 60 knots, this remaining distance of 20 nautical miles, your time of arrival at your destination will be Distance by speed 20 by 60 is equal to 20 minutes. Estimated time of arrival will be 14 hours 50 minutes plus another 20 minutes, that is equal to 15 hours 10 minutes. So correct option will be option Charlie, 15 hours 10 minutes. Next, airport elevation is given to you 1000 feet. So let's say this is your airport. There is a mean sea level where you find QNH 988. Elevation 1000. What is the approximate pressure altitude? Now pressure altitude is the altitude indicated by a altimeter when you set 1013 millibars in its altimeter setting window or 29.92 inches of mercury in it. So now elevation is always with respect to mean sea level, QNH. Pressure altitude is with respect to 1013 pressure level, standard pressure level of 1013. So you will have to measure your vertical distance from 1013 right now. Now you know this much is 1000. You must know this extra height, and then you will add 1000 and that, and you will get the total pressure altitude. So now what is the pressure difference between 1013 pressure level and 988? So 1013 minus 988 is 25 millibars. Now this 25 millibar of pressure difference is equivalent to a height difference of 25 into 30, because 1 millibar is 30 feet approximately. Accurately it is 27. So 25 into 30 is 750. So that means this is 750 feet. The difference between these two pressure levels is 750. Now our final pressure altitude will be equal to 1000 plus 750, that is 1750 feet. Okay, so this is your final answer. Next, aircraft starts at 4 degree 10 minutes south, 178 degree 22 minutes west. So let's draw this earth. There is equator. There is a point which is 4 degree 10 minutes south. From this point you head true north for 2950 nautical mile. You head true north for a distance of 2950 nautical mile. Now when you fly north or south along a particular meridian, you are actually flying a great circle track. So we are going to employ great circle distance formula here. So distance flying north is 2950 d lat into 60. D lat will be equal to 2950 by 60, that is equal to 49 degree 10 minutes. That means the difference between two latitudes, initial latitude which is this and our final destination latitude whatever is 49 degree 10 minutes. Now we all know that the difference between this point A, initial latitude, and our equator, the difference between them is 4 degree 10 minutes. Our total D lat is how much? Total D lat is 49 degree 10 minutes. Out of that, we will subtract 4 degree 10 minutes. Your aircraft is flying northwards, northerly direction. So it will travel 4 degree 10 minutes in the southern hemisphere and reach equator. So total D lat is 49 degree 10 minutes. Northward travel in the southern hemisphere is equal to 4 degree 10 minutes. Remaining dlat will be equal to 49 degree 10 minutes minus 4 degree 10 minutes, which is 45 degrees, which is 45 degree. So remaining dlat will be traveled in the northern hemisphere, and the new latitude destination will be 45 degree north. Longitude will remain the same, 178 degree 22 minutes. 178 degree 22 minutes. Now from this position B, we have turned 90 degrees right. 90 degrees right, that means this easterly direction. We are flying in the easterly direction. Now when we fly east or west along a particular latitude, we actually fly a rhumb-line track. So let's draw a new diagram. A longitudinal diagram for longitude, which is we are looking at the earth from the north pole, prime meridian, 180 east, 180 west, 90 east, 90 west. Now initial position 45 north, 178 degree 22 minutes west, 178 degree 22 minutes west. Easterly directions are anti-clockwise directions when viewed from the north pole. So our initial position is this. We are going to fly easterly direction. So our new position will be somewhere here, let's say. Okay, somewhere here. Now how to find that out? Drumline distance is d long in minutes into cos lat. Drumline distance is 314 kilometers. Convert that into miles, that is 169.7, approximately 170 nautical miles. D long into cos of latitude cos 45. So d long in minutes equals to 170 divided by cos 45, 0.7. So 170 divided by 0.7 is 243 minutes, or 4 degree, or 4 degree 2 minutes. 4 degree 2 minutes. Therefore, our new longitude will be initial longitude minus d long. Why minus? Look, initial longitude is 178 degree 22 minutes. When you travel east, the longitude value will decrease. 178 has become 90, 90 has become 0. If you travel west or clockwise, 178 will become 180. Increment has happened. Okay, but when you travel east in the western hemisphere, there will be decrease in value. That's why minus. So 178 degree 22 minutes minus 4 degree 2 minutes. So 20 minutes, and this is 174. So new position will be 174 degree 24 174 degree 20 minutes, or 22 minutes approximately, and latitude will be 45 north. So option Bravo is the closest option. You are heading 0802 and you have obtained a bearing from your airborne weather radar on a headland which is 30 degree left of the nose. So relative bearing is minus 30 degree to the left, or 330. Heading 0802. You have to find bearing to plot, that is to be plotted on the chart. Now when you plot bearings on the chart, those bearings are bearings bearings from the ground. Now in this case it is headland, It can be a beacon, any station. Bearings from the ground. Bearings from the ground means it can be QDR if magnetic, QTE if true. Now in this case we will find QTE because the heading given is in true. Now to find QTE, what is the formula first? First we will use we will find QUJ, which is true bearing to the station equals to relative bearing plus heading of aircraft. 330 plus 080 is 050. QUJ. QTE will be equal to reciprocal of QUJ, which will be equal to 050 plus 180, which is 230. So our answer will be 230 from the headland using aircraft's meridian. Using aircraft's meridian. Okay. Next, by what amount must you change your rate of descent if there is 10 knot decrease in headwind? So headwind component has decreased. Now what does headwind do to your ground speed? Headwind decreases your ground speed. Headwind decreases your ground speed, right? But luckily, if headwind itself decreases, the strength of headwind decreases, that is like saying, that is equivalent to saying your tailwind component has increased. Tailwind component has increased, right? So we will solve our question with respect to this phrase. Tailwind increased. Okay. Now it's given here that there is a tailwind component of 10 knots. Additional 10 knots. Now whenever there is a tailwind, your aircraft rate of descent will slow down. Aircraft will tend to float in the air. It will not come down easily. So as a pilot, you will have to correct this problem and deliberately increase your rate of descent. In headwind, you decrease your rate of descent. In tailwind, pilot intentionally increases rate of descent. Now the amount by which rate of descent will be increased is equal to 5 multiplied by change in wind component. That can be tailwind or headwind. So 5 into change in wind component is 10 knots. 10 knots increase in tailwind. So that is equal to 50 knots. That is equal to 50 feet per minute. The final answer will be in feet per minute. So no need for conversion. 50 feet per minute. So that means the pilot will have to intentionally increase rate of descent by 50 feet per minute. So the correct answer will be 50 feet per minute increase. Option A. Okay, 50 feet per minute increase. In which months is the difference between apparent noon and mean noon the greatest? Theoretical question you will find in Time 1 chapter Oxford book. So in the months of November and February, the difference between them is the greatest. 14 minutes, 16 minutes. So remember that. Okay. With this, we stop here. We will do the next questions in the next revision lecture video. I hope you have understood the questions I have solved in this video lecture and you have learned something new today. Keep learning, keep watching the other videos as well. I have made plenty of videos on time chapter, 1 in 60 rule, convergency, great circle, departure. Watch those videos, revise your concepts, refine them and score good marks in your exam. Subscribe to this channel and share this video with your friends so that they also get help and benefit from this video lecture. I'll see you in the next video. Till then, take care, be safe, all the best.